Hello everyone, and welcome to another video in my channel. In this video, we'll have a very nice exponential challenge to solve. It is actually a math Olympiad challenge from China. What are we going to do to solve this problem? What I'm going to do first is to apply a law in indices, that is the addition law. If I have a raised to power x times a raised to power y, it can be written as a raised to power x plus y. So this part of the law is of the same form as this part of the equation. So that becomes x raised to power x is equal to 3 raised to power x times 3 raised to power y. The next thing I will do is to divide both sides by 3 to power x because I want all the variables to be on one side and the constant to be on the other side. So dividing both sides by 3 to power x, I have x to power x over 3 to power x is equal to 3 to power x times 3 to power 1 over 3 to power x, where this and this can cancel out, leaving us with x to power x over 3 to power x is equal to 3. I will also apply another law in indices. That law is this. If I have a raised to power x divided by b raised to power x, it can be written as a over b all raised to power x. So it becomes x over 3 all raised to power x is equal to 3. The next thing is to ln both sides, or to find the natural log of both sides. If I write ln x over 3 here to power x, I must also write ln of 3. Now this power will now come down. That is x times ln x over 3 is equal to ln 3. Now what am I going to do next? I want to apply the Lambert W function. If I have x to power e to power x is equal to a constant, then I can find the Lambert W of both sides. Now, since this base and the power are the same, so W x times e to power x is also x. So what am I going to do in order to make this to be of this form so I can take the Lambert W of both sides? I'll first of all concentrate on this part. If I have e to power ln x, it is also equal to x. So instead of writing x, I'll write e to power ln x. That becomes e to power ln x times ln x over 3 is equal to ln 3. The next thing I will do is to multiply both sides by e to power minus ln 3. So it becomes e to power minus ln 3 times e to power ln x times ln x over 3 is equal to ln 3 times e to power minus ln 3. Let us rewrite this part as ln 3 times, now this is e to power ln 3 minus 1. Now this one can be rewritten as ln x over 3 times e ln x times e minus ln 3. Good. Now in this part, I'm going to apply the subtraction law of logarithm. If I have ln a minus ln b, it can be written as ln a over b. So what I have now is ln x over 3 times e ln x over 3 is equal to ln 3 times, now this one can be written as 3 to power minus 1. Now we see that the base and the exponent are the same, so I can find the Lambert W of both sides. So I'll W this side, ln x over 3 e ln x over 3 is equal to W of ln 3 times 3 to power minus 1. Now, rewriting this part, I have W of ln 3 over 3. And why this part remains the same? Or I can now apply this Lambert W property, which is this. So since I have the base and the power the same, I have ln x over 3 is equal to this. Let's find the exponent of both sides. If I have e to power ln x over 3 is equal to e to power w ln 3 over 3. So I'll have x over 3 here is equal to e to power w ln 3 over 3. Now multiplying through by 3, I I have x equals to 3 times EW ln 3 over 3. So when we punch our calculator for this, we are going to get this. So x equals to 3 times E. So x equals to 3.959, or x equals to 3.96 to 2 decimal places.